right, everybody. So here is video 2 for activity 3. Why is lightning so much bigger than a spark from a Van de Graaff generator? This time, we're looking at factors that affect the magnetic potential energy. Now, this is going to be a little different because, again, we've never had a simulation that deals with magnets. So we're going to show you guys a little bit of hands-on experience with magnets, but just as a reminder, some of these same principles that we've dealt with electrical potential energy, they're the same principle as a magnetic potential energy, as in you can use the simulation from activity 2 to help explain that. But we don't really use charges for that. Mr. Gilbert, can you explain more about magnets? What are magnets and what do they look like and why don't we really use charges?
All right, so the major difference than in the simulation that you did, in the simulation with electrical potential energy, you have a positive and you have a negative. So if you can read these magnets, you can see that it says N and S, all right? You don't see positive or negative, okay? N stands for north, S stands for south, and those are poles. So they're not charges, but they have the same principle because when I have S and S, these repel one another, okay? So it's like a like, and for electrical, we say like charges. Now we're saying like poles, so that's why it repels. If I take the north end of a magnet and the south end, and I put them together, they're going to attract because it's just like an electrical charge where they're opposite. But they're not essentially the same thing. And I think for the purposes of what we're doing this year, it's not really that vital for us to go in and talk about how a magnet actually gets its strength. Just for the purpose of this, you need to know that magnets have poles and not charges.
All right. So again, we're going to start on page 3 of activity 3. We need 2 pairs of magnets. There's going to be a strong pair and a weak pair. You're going to have to figure out which one is which. And we have a spring. A spring is going to act as our metal substitute for a paper clip. So it's going to say, identify which magnets are stronger and which magnets are weaker. It's going to ask to justify your answer. So you're going to watch Mr. Gilbert kind of play around with these magnets. Listen to what he talks about because those are going to be your justifications. So go ahead, Mr. Gilbert, play around with these and you try to figure out which one is stronger and which one's weaker.
Okay, so I think that in order for me to figure out which pair of magnets is stronger or weaker, I'm going to think about like when they become attracted or repel from one another. So I'm kind of thinking back to the simulation that we did with electrical potential energy, and I'm going to think that whichever one attracts greater or repels greater, I'm thinking about force. So if one of these magnets moves with a larger force, or you can see it move with a larger force, maybe it's going to move faster, I'm going to say that that's probably a stronger magnet, and then the weaker magnets won't move the other magnet as much. So I'll start with these right here, and this is the south end, and this is the north end, so these should attract. So let's see what happens. Okay, and now I'll show when they repel, so let's see what happens. Okay. And now I'll try this other pair of magnets. Now these are different because they don't have north and south ends, okay? So you would have to figure out based off of whether they repel or attract. So I'm just gonna put one here, and I'll put the other one right here, and I'm gonna move it towards it because right now they're not interacting. So let's see what happens as I get closer to it. Let's see what happens.
What happens, Mr. Gilbert, like, remember, we've discussed last class that all of the potential energy is actually stored not in the magnets. It's in the magnetic field itself. So what's happening as you bring these 2 magnets closer together?
Well, let's think about that based off on the simulation, too, is right now, it appears that I have them set up that they're going to attract, right? So right now, you would assume that in this area right here, there's a magnetic field that we cannot see, and the field is not interacting yet. But as I get closer, here's what's going to happen. Right now, there should be a large amount of potential energy in here because the natural process is for these 2 to attract to one another. So there should be a greater amount of potential energy stored right here, all right? But right now, there's very little force. But when I get closer, you'll begin to see that this one will start to move, which means that potential energy that's in here is now going to be turning into, see, it's trying to turn into kinetic. And then that's what you see.
So wait a minute. Where'd the kinetic energy go, guys? Nothing's moving. So
So you guys should know that, like, you know, and we know that the simulation didn't show you this, but we've talked about it. You know, we have a large amount of potential energy is being converted to kinetic, and now there's no movement at all. So where did the energy go?
You guys should be able to answer that question. If not, turn to the person next to you and ask.
So let's try what it looks like when I repel too. So again, we have repulsion, right? Now at this point, it's a little bit different, right? So when I get in here, oh no, yep, there we go. All right, it's going the other way. Okay, so now the difference is there's more out here. There is very little potential energy. Okay, but when I move closer, you can see the potential energy now, because what's going to happen is this guy is going to go flying, and that's what happens.
Okay, so basically, you're basically saying, so the closer when they're repelling, the stronger it gets, because that potential energy ends up converting, and to get them to quickly move, you need lots of kinetic energy, right?
Right, so then there would have to be, based off of what we learned from the last simulation, right now there would be very little force, right? But when I get in here, the force is going to be greater.
Okay. You guys should be able to answer question 4 based off that discussion. Identify which magnets are stronger and which ones are weaker. Justify your answer. Let's take a look at number 5. Experiment the magnets and feel the force between the different pairs of magnets at different distances. Which pair stores the most potential energy in the field? Well, kind of sounds like Mr. Gilbert kind of talked about in general what the fields look like when it's repelling and when it's retracting. Or repelling, I apologize. But now we got to look at what that looks like for different strengths of magnets. So play around with these, Mr. Gilbert. Let me know what you think.
All right, so you know we haven't identified which one is stronger, but I think it's pretty obvious. Okay, so right now these are set up to repel, both sets of magnets. Okay, so they're at equal distance probably, right? So let's see what happens. So you guys need to be thinking, and again, it's just like the simulation. So if I have, opposite or same charges, all right, then right now, all right, you should know that because they're far away, there's very little potential energy and there's very little force, okay? But you got to realize their natural movement is to repel one another. So when this gets closer, you're going to increase the PE, all right? Because now what it wants to do, once it gets close enough, it's going to send this one flying. All right, and you can see I didn't even have to get really that close to it.
I mean, you got...
It's about right there.
That's it. Okay.
Okay. So the distance is still pretty far, all right? And then you saw what happened. Now let's try these guys. So these are the same, magnets, right? Well, they're different magnets, rather. But we're going to see what happens when this one gets near it.
Okay, that was like... Here?
Yeah. So, yes. So you can see that obviously in this area, even though that these are the same distance apart, the strength of the magnet is going to determine how much potential energy is going to be in between the magnetic fields. So obviously, without me giving you the answer, you should see what's happening here. Which one has less or more PE?
Hint, hint, justify your answer for number 5. Use some of the things that you saw and Mr. Gilbert talk about for number 5. Number 6. Experiment with the arrangement of pairs of magnets that attract and repel. Compare what you feel and what you think might be happening to the amount of potential energy associated with the magnetic field. Again, I feel like Mr. Gilbert did a really good job already explaining what's going on with the magnetic field at different distances and with magnets of different strengths.
So we can show it, last time we showed it repelling, now we'll show it attracting.
That's a good idea.
So I'll set this up so that these magnets should be attracting to one another. So again, the difference now is these magnets naturally want to try to come together. Because of that, there's going to be a large amount of PE, magnetic potential energy in here. Okay, and it's the same principle. Right now there is very little force, but when they get closer, you're going to see a strong force. So let's see, and you can see that it's already starting to move.
Yeah, look at that green side of that magnet. It's definitely wobbling. And it's not, Mr. Gilbert's not shaking the table.
So you can see what happens.
I mean, that was like here.
Yeah, and the other one was pretty far away.
That was when that was there.
Yeah. Now we'll show these magnets, okay? And again, it's the same principle. Like, we're trying to figure out which one has more magnetic potential energy in here, all right? So right now, little force, there should be some potential energy in here, right? And then as I get closer, you're gonna see what's gonna happen, and that's what happens.
All right, so you can use that demonstration to actually answer number 6 and 7, which 7 says, describe which two magnets you would use and how you would arrange them in order to have the most potential energy in the magnetic field. So use that last clip to answer question 6 and 7 for activity 3 on page 3 of Concord Interactions.